Today we're going to be learning about solving systems of equations. This is something that you've done in the past, so hopefully when we go through it, you'll start to remember what you're doing. For today, we're just going to go through one of the three methods, and we're going to take a look at graphing. The other two methods are algebraic methods. They include solving systems by substitution and solving systems by elimination. We'll do those tomorrow. If you read along here, it says a system of equations is two or more equations with the same variables. So typically I use x and y just to give you guys a heads up on that. To solve a systems of equation with two variables, you find the ordered pair that satisfies all of the equations. When we check our answers, we must be sure to check them in all equations, since a correct answer for one equation may not be correct for the others. You can solve a system algebraically or by graphing. You will obtain the same solution with every method. Today we're just doing graphing. Again, we'll do the next two methods tomorrow. Today we're going to focus on solving systems of equations using the graphing method. When you're graphing equations, there's multiple methods you can graph in. Two of the most common are standard form and slope-intercept form. So I'm going to briefly go over each of the forms just as a review from Algebra 1. You do need to know how to graph in both forms this year. Both equations that I gave you, x plus 2y equals 4, and also 2x minus 3y equals 1, those are both in standard form, so we'll start with that. So just a couple quick notes when graphing in standard form. When you're graphing in standard form, you need to find 2 points. You have to find where the graph crosses the x-axis. The x-axis is this line here. So we need to find the point where the graph crosses that line I just highlighted in yellow. And we need to find where the graph crosses the y-axis, which is this line highlighted in green. That's called the y-intercept. So we're looking for both the x and y-intercept. We'll start by finding the x-intercept. And just a quick note, the x-intercept is where the graph crosses the x-axis. Okay, to find the x-intercept, the directions are set your y variable equal to 0. So replace y with the number 0 and solve for x. Once you solve for x, that number is your x-intercept. To find the y-intercept, it's a similar process. Real quick, the y-intercept is where the graph crosses the y-axis. Similar to the x-intercept, but using the opposite variables. So in order to find the y-intercept, you would have to set x equal to 0. And once you do that, you would solve for y. Okay, so in this graph here, your x-intercept is where it crosses the x-axis. I have the x-axis highlighted in yellow. You are solving for x in order to find that. The y-intercept is where the graph crosses the y-axis, highlighted in green. You are setting x equal to 0, and you are solving for y. Using these directions, let's focus on the first equation. The first equation is x plus 2y is equal to 4. We're going to start by finding the x-intercept. In our directions to find the x-intercept, we have to set y equal to 0, we're going to take this original function, which is originally x plus 2y. We are going to replace y with 0, and this is equal to 4. When I solve for this, we have x plus 2 times 0, which is 0, and that is equal to 4, or x is equal to 4. This number is where the graph crosses the x-axis. So I like to make sure I write my x-intercept as an ordered pair because it is specifically a point where the graph crosses the x-axis. So to finish this, I would say that the x-intercept is at 4, 0. And those numbers are from my value of 4 that I solved for. And we originally substituted in a y value of 0. That's where those numbers are from. Okay, so to graph this, x equals 4. Look at your x-axis. Plot a point at 4, specifically at 4, 0. That is your x-intercept. All right, now let's find our y-intercept. Following the directions above, the y-intercept is found when you set x equal to 0. Using our function, we have 0 plus 2 times y is equal to 4. When we solve for this, we have 2y equals 4. Divide both sides by 2. And y is equal to 2. Again, I like to write as an ordered pair because it is a point on the graph. This is at 0, 2. These numbers are because the x value is 0, we substituted that in. And we solved for y, we came up with a y value of 2. Now we need to plot this point on the graph. We're plotting a point at 0, so over 0, up to 2. And this right here is your y-intercept. Okay, once you have those 2 points, you're going to connect them with a line, and that is your graph. Okay, that's our first function. So I highlighted that function in purple, and I just drew that line in purple. Next, let's take a look at the second equation, which is 2x minus 3y equals 1. Because we already graphed the first line in standard form, I'd like to graph the second line in slope-intercept form. So let's just write a couple notes off to the side on what slope-intercept form is. All right, so when you are graphing in slope-intercept form, you need to make sure that your equation is in the form of y equals mx plus b. And once you have it in the form of y equals mx plus b, b is your y-intercept. And m is your slope value. So slope is always rise over run. Your slope is generally a fraction, so whatever your top number is how far you rise. Whatever your bottom number or denominator is how far you run. If you have a whole number, such as the number 2, then it would be 2 over 1. That means your rise, for example, would be 2. Rise up 2 units. Your run would be 1. That means you run 1 unit. That's just an example, but make sure you know you can still use whole numbers here. So one thing about graphing in slope-intercept form is that you need to make sure you get your equation into this form here. So you might have to do some rearranging of the original expression in order to use this form. So let's go ahead and look at the second equation, and let's do some rearranging, move this around, and get this to the correct form to use slope-intercept. Our equation is 2x minus 3y equals 1. We want to isolate the y variable, so we need to move everything that is not with the y variable over to one side of the equation. That means I am going to subtract 2x from both sides. That's removing 2x from the left side of the equation. I'm left with negative 3y equals negative 2x plus 1. Then I'm going to divide everything in the equation by 3. The reason why I'm doing that, I should say negative 3, is because I need to isolate the y variable. That means y needs to be alone. It can't be with anything else. Can't be multiplied, can't be as a division problem. It needs to be alone. So I'm going to divide every term on both sides of my equation by negative 3. This will give me the form of y equals negative 2x divided by negative 3. Your negatives will cancel, so I am now left with 2 over 3x plus 1 over negative 3, or negative 1/3. This here is in slope-intercept form. So we're going to use negative 1/3 as our y-intercept. And we're going to use 2/3 as our slope. When I come down to my graph, first I'm going to graph my y-intercept, which is negative 1/3. So do your best to be accurate with this point. I would say it's about right here. And my slope is telling me to rise 2 units. Be careful because this is a fraction, so you do have to count accurately. So rise up 2 units. This would be 1 unit, 2 units. And run 3 units. 2 over 3 is rise 2, run 3. So I'm running 1 unit here, 2, 3. So my point would be approximately right here. You can do this as many times as you want. You can go in either direction. So I just went up 2 units over 3, but I could also go down 2 units, so down 1, 2, and then run 3 units, 1, 2, 3. You can do this as many times as you want. I would do it enough times to just make sure you can get a good line going through all of your points. All right, once we have all of our points, we are going to look for the point of intersection. The point of intersection is going to be the solution to the system. In this case, our point of intersection is right here. That point is at 2, 1. That is your solution. This here is the solution of the whole problem. Now there is one way you can check your answer. You can take 2, 1, and you can substitute it back into both of the original equations. And when I say the original equations, I'm talking about these right here. And you can make sure they come out to be true. If they come out to be true, then you know your check is correct and you did the right thing. Let's take these equations, our original equations, and our solution, and let's do a quick check.